So we finally hit our final unit, our fourth and final unit of discrete mathematics, and this is a really big area of discrete math called graph theory that we're delving into. This is chapter 10. So we're going to introduce a lot of terminology, do a little bit with graph theory the last few weeks here. So we want to define what is a graph in the context of graph theory. So definition. A graph, so we're defining G, that consists of two sets. First of all, a set B, which we're going to call the vertices, and another set E, which we're going to call the edges. So it consists of basically vertices of edges. Consists of capital V. I already said that, right? Capital V is non-empty. Set of points, which we call vertices. And another set E, capital E, which is a set of associations, a set of associations between those vertices. And these are called edges. Okay. So let's just draw a little picture here. So I have 2 points. These are going to be my vertices, A and B. So my vertex set, V, is going to consist of a set of 2 points, right? A comma B. And let's say I want to connect those 2 points with an edge. So I have a single edge. So this is, let's say this is my graph. This whole entire thing is my graph here. This 2 points with an edge. So my set E consists of a single edge. The way we're going to write that, it's going to be the set containing A comma B. So order doesn't matter here. You could have also have done B comma A. That would have been fine. If you wanted to, you could have put, instead of A comma B, you could put B comma A to indicate that particular edge. Well, so you can go either from A to B that direction. Starting at A, you can go to B. Or you can go from B to A. You can go back and forth either way. So there's my edge right there. And there are my 2 vertices, A and B. So A and B are the 2 vertices, and the edge is B comma A. It's in a set. All right, so notation. So the notation here is, we just said it a moment ago. A comma B or B comma A, either one of these denotes the edge joining vertex A and vertex B. So the edge actually is that set of 2 elements. So edges consist of 2 elements. Set containing 2 vertices. All right, so let's see. Here we go. Here's a little example just to get used to this notation. Let's consider this graph. AB, C down here. Then we have, let's see, D here, and then up here we have E. So let's write our vertex set first of all. Our vertex set is going to be V, You're just going to list all your vertices, right? Your points. A, B, C, D, E. All in a set, right? They're all in a set. Then you have to list all your edges. All your edges. So our first edge that we encounter here, let's see. We encounter A comma B, so that's going to be in a set, A comma B. All right, that's our first edge. What else do we have? B comma C. Doesn't matter what order you put these edges in. I'm going to put them in. Just count them down. Okay, we do A comma C. That edge. All right, keep going. Let's delete this for now. All right, what do we have left? We have C comma D. Oh crap. Oh man. Man, this black is not. There we go. That's what happens. Technology for you. Where were we? We got AB, BC, AC. We're about to do CD. There we go, CD. It's an edge. We have to do what? DE. Put a comma first, and then we can do that edge DE. As in differential equations, right? Your favorite. And finally, AE. AE, that's our last edge. So an edge consists of a set of two vertices. All right, there we go. So the big blue, that's the set of all the edges. So the green are the edges. The blue is just the set containing the edges. So the set of edges. All right. So vertices and edges, just getting used to the notation there. Here's another definition. What is a loop? A loop. A loop is an edge with only one vertex. An edge with only one vertex. Just a little example of a graph here. Let's say I got a triangle. A, B, C. Then we're going to add something here on B. We're going to have exactly what it sounds like, a loop, right? So here, you think about this edge here on the side, that loop there. It starts with B and it ends with B. So it turns out that B comma B, which you can also write as just singleton B, right? When you have a element repeated, you have an element repeated in a set, you can just write it as a single element, is a loop. A loop, right? It's an edge with only one vertex. So if I were listing all of the vertices here, just the vertex set, I'd have what? A, B, and C. I'd have those three vertices, right? A, B, C. And when I'm doing my edge set of edges, first of all, I'd have like AB, right? We got from A to B, that's an edge. We have from B to B, which is just B itself, singleton B. And then you have from B to C, so another edge. And then you have from A to C, your last edge. And we're going to close that off with the blue parentheses. Okay, so I should actually have maybe these blue commas right here to separate the edges. Okay, so those are all the edges. So notice that the singleton, right, the singleton right there, singleton B, that's the loop. It's from B to itself, which is just singleton B. All right, just getting used to notation here. Here's another definition. definition. A multi-edge or a multiple edge. That's what we're defining. So we defined a loop. Now we're defining a multiple edge of multiplicity m. Multiplicity. Let's see, change the letter. K, let's say K. A multiple edge of multiplicity K is an edge that occurs K times in the graph. Let's just draw a little example of that. No, we don't want to do an example yet. We'll do an example here in a little bit. All right, we want to define one more thing. So we got a multiple edge, a multiplicity K. That's an edge that occurs K times, shows up K times. So for example, you had a multiple edge of multiplicity 2 that would show up 2 times. So what about a multigraph A? Multigraph is a graph with multiple edges but no loops. That's the way most books define a multigraph. Okay, so let's actually do an example of this multiple edges thing. Okay, so I got a little picture here. I got A, B, and C. I got my 3 vertices. We have an edge from A to B, an edge from B to C, and then we have another edge from A to B. Okay, so let's note that AB here, from A to B, you got 2 of those edges. So A to B is a multiple edge with M stands for the multiplicity. The multiplicity of that edge, A comma B, that's equal to 2. So M here is a function that tells you how many times that edge shows up. It shows up twice. So if I were actually listing out all my vertices, I'd have, what, 3 vertices. I'd make a set of 3 vertices, A, B, and C. And then my edges, let's say I wanted to do my edges. All right, so it looks like we just have 2 edges. Right, you have first AB, that's an edge. And then you have a second edge, right, BC. So you have 2 edges, but you need to specify the multiplicities of your edges. So notice that AB is a multiple edge. So we're going to write here now M of AB is 2. And we have to specify the multiplicity of BC. M of BC is 1. So when you have a multigraph and you want to properly write out the vertex set and the edge set, you only specify that AB shows up once in the edge set, right? You only say AB is an edge. You don't repeat AB, AB. You don't repeat it in the edge set. But you need to specify their multiplicities. That's the way you write that out properly. All right, so more terminology. So we defined a multigraph. So a multigraph had multiple edges but no loops. Now we're going to find something called a pseudograph. Definition. A pseudograph. That's a graph with loops, and it may have multiple edges. A pseudograph is a graph with loops. So it has to have loops and may have multiple edges. It doesn't have to have multiple edges. May is the key word here. But it definitely has to have loops. So let's just do a quick example. Not writing too well today, are we? Okay, let's say I just have two vertices here, A and B. And let's say we connect these guys with an edge that's repeated, and then we have a little loop here, B. So this is an example of a pseudograph. This is a pseudograph, right? You have a loop, and you have multiple edges. So here we have a pseudograph. This is a pseudograph. Now, if you actually wanted to write out the vertex set properly and everything, you could do that. So the vertex set consists of what? Just two vertices, A and B. And the edges get interesting. You're just going to have two edges. One of them is repeated. So first of all, you're going to have AB, right? AB is one of your edges. It's a set containing A and B. That's your first edge. Then your second edge is just going to be the loop B. So we'll just put, rather than writing B comma B, we'll write singleton B. And we close that off. Now, because the pseudograph has a repeated edge, right, an edge that's repeated, we have to put down the multiplicities. So we're going to say that the multiplicity of AB, that's the repeated edge, is 2, and the multiplicity of singleton B, well, that loop just shows up one time, so it's 1. So you can write all that out if you want to. All right, what else? How are we? I think maybe we'll stop right there and we'll move on with more terminology and notation in just a bit.